Hello and welcome to this video on the practice of distance time and the speed time graph. The theory for these we have already covered. If you have not gone through the theory, please do cover the videos. Go through the videos on the theory of speed time and the distance time graph. So here we are on practice question number 1. So the figure here shows a distance time graph for a moving object. The graph that you're given here is a distance time graph. Describe the speed of the object between the points A and B. They're talking about point A and point B. Point A and point B. What kind of a pattern of the graph do you see between point A and B? It is a curve, right? It is a curve, and we understand that the curve can be of two types, a downward going curve or a upward going curve. But the curve here in this case, it is a downward going curve. So downward going curve automatically means that this is a deceleration happening here. This is deceleration. You can say deceleration or you can say decreasing speed. Decreasing speed same as deceleration. Between the points B and C. If you talk about point B and C, what kind of a graph do you see between point B and C? It is a straight line. It is a perfectly straight line. So, and we understand when it is a straight line on a distance time graph, straight line has a constant gradient throughout. So this is your constant speed. Constant speed. Other answers which you can possibly give here is zero acceleration. Constant speed means you are not accelerating, increasing your speed. You are not decelerating, you are not decreasing your speed. Instead, you are running at a given constant speed. Right? So it is a constant speed. Other answers that you can give are no acceleration, right? If you say zero acceleration, that also is a correct answer for the part 2 of question number A. Let us come to B. State whether the acceleration of the object is zero, negative or positive as shown in the graph between A and B. Is the acceleration positive? They are talking about acceleration. Between A and B, we have understood that this is a deceleration. So the acceleration has to be, deceleration means negative acceleration. The answer that comes here is negative. Why? Between A and B, is the acceleration negative? Because between A and B we have already stated that this is a deceleration, and deceleration means negative acceleration. Between point B and C, we have already stated constant speed means no change in the speed, you are not accelerating. So not accelerating means zero acceleration. Simple. Now part C, calculate the average speed of the object during the 40 seconds. They are talking about the entire range of time starting from here till the last point. So what is the average speed? Now if you see that the speed is different at different points in this distance time graph, it is not a scenario of constant speed. How do you find the average speed? Total distance over total time taken. Average speed, the formula is your total distance over the total time taken. So how much is the total distance? 50. In 50 seconds, the total distance which is traveled is 50 over 45 over 4, which is 1.25 meters per second. Alright. So if this question is well understood, let us move on to the next question. Okay, interesting question on a comet. A comet is traveling in space. It enters the atmosphere of a planet. its speed time graph. Figure this is the speed diagram of the comet from the time 0, right? From time 0 onwards, you are given the speed time graph. Let us come to part A. Part A. During the period time t is equal to 0 to time t is equal to 6 seconds, both the speed of the comet and the velocity remains constant. They are saying the speed and the velocity remains constant. Suggest what this suggests about the motion of the comet. So they are talking from this time period, which is 0 till time period 6. So where do you think is 6? So 4, 5, 6. So 6 would be somewhere here. Speed and velocity both are constant. Velocity also constant means that the velocity has the same magnitude and the same direction all throughout. So what does it mean? It means that the speed is not changing as well as the direction is not changing. So suggest what this state about the motion of the comet. Constant speed, or you can say it is maintaining a constant speed with no change in direction. Why the direction is also not changing? Because if you change the direction, even if you are maintaining the same speed, but if you change the direction, the velocity changes. Say that if you are moving in this direction at 20 meters per second, and you change the direction this way and still keep moving at 20 meters per second. Moving this way, direction goes different, right? But the speed is the same, 20, 20. But since the direction is changing, the velocity is changing. But here what they are saying, that the velocity also does not change. Velocity also does not change. When does it happen? That the speed is the same as well, the direction is the same. Constant speed with no change in the direction. Determine the distance traveled during the period. Let us come to the second part of the question. Determine the distance traveled from the time t is equal to 0 to t is equal to 6. T is equal to 0 to t is equal to 6. Alright, so you have to find the distance traveled. It is a speed time graph. So from the speed time graph, how do you find the distance? It is the area under the graph, right? So this is a rectangular figure here. So finding the area is also simple. The width here is 6. And how much is the height? Let us find out. 31, 32, 33, 34, 35, 36. 36,000. So how much is the distance traveled? 36,000 multiplied by 6. This should give you the answer. So which comes out to be 6, 6 are 36, 3, 18 plus 3, 21. This is a 0. Alright, so you got the distance traveled, which is the area under the speed time graph. Why area under the speed time graph? Because that's how the distance is found out in a speed time graph. Let us come to part B. Explain what the graph shows about the motion of the comet between time t is equal to 0 till time t is equal to, time t is equal to 6. So they are talking about time t is equal to 6 till time t is equal to 10. So let us find out where is 10. 10 would be somewhere exactly in the middle here, between 8 and 12, right? So explain what the graph tells you about the motion of the comet between time t is equal to 6 to 10. So they are talking about this part of the graph. So what is happening here? It is a speed time graph going down. It is a downward going curve, right? What do you say? It's a downward going curve. Speed is decreasing. If you see the value of the speed going down from this value to this value to this value, the speed is going down. So what does it show? It is a downward going graph. It is a negative slope graph. It shows deceleration. That should be your answer. Simple. Now part C. Determine the acceleration of the comet at time t is equal to 11. So time t equal to 11 would be somewhere here, right? It would be somewhere here. So how do you find the acceleration? It will be given by the gradient of this line. If you see, this is a straight line section of the graph. You need to apply the formula for the gradient here to find the acceleration. So let me erase some extra stuff here to bring in a neater picture, and let's mark the line that we are talking about. Say that we are talking about this section of the line, the red section of the line. Let's take 2 coordinates on this line. Take two points and write down the coordinates. So this is 12 and say 13,000, sorry. Take one other point, this one, right, somewhat like 9 and 20,000. Here you can take one of them as x1, y1, the other one as x2, y2. How do you find the acceleration? Acceleration will be equal to the gradient. M means gradient. y2 minus y1 over x2 minus x1. Substitute the values of y2, y1, x2, x1. They should give you your answer here. And you'll see that the acceleration that you'll get here will have a negative sign. It will have a negative sign. Negative sign means it is a deceleration, decreasing speed, and that is quite evident from the graph because it is a downward going curve, right? Clear? So let us come to the last part of the question, the D part. Suggest what happens to the comet at time t is equal to 12. So if you see time t is equal to 12, the speed has suddenly come down. Speed has suddenly come down to 0. So from this particular value of the speed, which was quite high, it was something like 12,000 at this point, the speed came down to 0. From 12,000 speed, the speed came down to 0 value. This could have happened, a sudden drop in speed, maybe the comet crashed on the planet. Sudden drop. It hit the planet, sudden stoppage happened, sudden stop happened, and the speed suddenly went down. Alright, so if this question is well understood, let us move on to the next question. If this is not understood, please rewind the section. You may go through this again. Now, question number 3. The figure here shows the distance time graph for 3 different objects, A, B, and C. You are given 3 objects, A, B, and C. Describe the motion of each of the objects A, B, and C by selecting the appropriate description from the list below. So before you talk about the description, let us first see what kind of a graph it is. It is a distance time graph. Okay, so for the object A, what kind of a curve is it? It is a curve, but upward going curve. So on a distance time graph, an upward going curve represents increasing speed or acceleration. So the answer for A should be this, increasing speed, right? Or acceleration. AB, not AB, sorry, this point. Object B. It is a straight line graph. Straight line, it is not a curve. Distance time graph, when it is a straight line, it is called constant speed. So this is your answer here. C, flat line. Distance is static. The time values are changing, but you're stuck at this value of distance. What does it mean? You are stationary. Alright, so all these things, all the theory we have learned very well in our theory section. If you do not understand these questions, then that means you need to go to the video on theory, because the videos on theory are very well and very nicely explained. Fine, so let us come to the part B. The figure here shows the speed time graph for 3 more objects D, E and F. Now this is a speed time graph. Speed time graph. Describe the motion of each of the objects by selecting the appropriate description from the list below. Now let us look at D. D is a curve which is going up. Curve is going up. What does it mean? It means acceleration, but an increasing acceleration. This is your answer, because it is an upward going curve, so increasing acceleration. And if we talk about point E, the object E, it is a straight line, it is not a curve. Straight line means constant acceleration, and a flat line means zero acceleration or constant speed. So these are your answers. F means constant speed or zero acceleration, because zero acceleration option is not given here. The most appropriate that we see here is constant speed, which is same as zero acceleration. So these are your answers. Please do not forget to check out the video on understanding terminal velocity, and as well as there is a separate video on solving the questions on terminal velocity. Thank you so much.